Okay, here's a percent of change problem. The average cost of 1 gallon of gas last August was $3.25. This August, the average cost per gallon of gas was $2.27. What was the percent of change in the price? So there's some information here. We're given the price of a gallon of gas back in August, which last August it was $3.25. And then we're also given this August, it is $2.27. So those are our two numbers. And we want to know what's the percent of change in the price. So the price has changed. We want to know how much it's changed, and of the amount it's changed, what percent of the original was it? Because we want to compare it, like, did it go down? Did it go up? How much of the original did it go down? How much of the original did it go up? So our formula for this is percent of change equals the amount of change, how much change there between the two things, over the original amount. So the amount of change is going to be the difference between those two numbers. And many of you know that difference means subtract. So we're talking about the percent of change. We want to know the amount of change, so how the difference between these two. So I'm always going to start with my larger number, not because I'm afraid of negative numbers, but because it doesn't need to be a negative percent of change. I can tell whether it's gone down or up by saying it was a percent increase or a percent decrease. And I'm going to look at that kind of when I'm done to see if it went down or went up. So I don't need a negative number. I'm always going to put that larger number first. So when I subtract, it's going to be positive. And at the bottom, I've got the original amount. Now, how do we tell when an amount is original? We're going to look for time words. In this case, last August versus this August. Which came first, last August or this August? Last August. It's farther away than this August. Sometimes you might see words like now, or it was, or is, or he bought it before and now it's on sale. So you have to think, what happened first? In this case, what happened first was $3.25. So we're going to figure out how much it's changed since it was $3.25. So we take our calculator out. $3.25 minus $2.27 is a 98-cent difference. So when we rewrite this percent of change, it's going to be 98 cents over $3.25. And we're going to divide because we want a percentage here. So 98 cents divided by $3.25, that's going to give us 0.3015. That doesn't look like an appropriate percentage to me, and that's because we haven't divided by 100 yet. We haven't changed that decimal back into a percentage. Up here, this is really a proportion. This guy right here, this is really a proportion. Percent of change, if you guys like using proportions instead of equation, just imagine percent of change over 100, and you're really going to get the same answer. Here, I'm going to have to move my decimal afterwards. Here, if I use it as a proportion over 100, it'll move my decimal as part of my problem. So whatever you're most comfortable with. But I have to move my decimal over. So now I have 30.15. And if I'm rounding to the nearest tenth, which many of us have difficulty with, and maybe you just rounded in properly, I'm going to look next door at the 5, and the 5 is going to tell me if I'm closer to 30 and 1/10 or if I'm closer to 30 and 2/10 if I'm going to go up to 2. 5 is right there on the top of that hill there, so it's going to roll down to the next tenth. So rounding this is actually 30.2. 30.2%. Now, was that an increase or was that a decrease? Well, let's go back. It started last August at $3.25, and now it's $2.27, which is cheaper. So the price has actually gone down. Going down is called a decrease. Raising up is called an increase. So it's a 30.2% decrease from last August.